Welcome to this lecture, Hydrogen Basics. In this lecture, I will present what is hydrogen, where do we find it, where are we using it, and why is it such a hot topic nowadays. Let me start. What is hydrogen? Hydrogen is the lightest element in the periodic table. It has one proton and one electron. In fact, when we talk about hydrogen, we typically mean the hydrogen molecule, H2. And H2 is a colorless, odorless gas. It gets liquid at temperatures below 253 degrees centigrade. It is in fact the most abundant element on Earth. However, it is mainly found in combination with other elements, such as hydrocarbons in all living matter in plants and animals, and the biggest source of hydrogen is in fact water. One of the interesting properties of hydrogen is that it reacts with oxygen to form water in an exothermal reaction. And let me just give a few more details on this specific process. Already more than 200 years ago, the chemist Döbereiner invented a device where he exploited the reaction of hydrogen and oxygen to give water. He exploited the property that when you bring a non-noble metal, in that case zinc, in contact with an acid, here sulfuric acid, you see the bubbles coming up here, then hydrogen is formed. When you then release the hydrogen through a nozzle and bring it in contact with a platinum sponge, which acts as a catalyst here, then the reaction of hydrogen and oxygen to water is a very smooth reaction, evolving heat, and the platinum sponge, the catalyst, becomes so hot that you can ignite a wood stick, for example. And it's actually for this reaction that hydrogen has become into a big focus quite lately. But then, let me look back. Where do we get the hydrogen from, and where are we using it? I mentioned that hydrogen is found in connection with other elements, with a source. We have to put energy into the process, and then we can extract hydrogen. We also obtain byproducts or emissions. From the produced hydrogen, we cannot see which source we have been using, or what type of energy was involved, or what type of byproducts or emissions we have produced. In order to be able to assess this, a color code was developed, the so-called hydrogen color wheel. It is not standardized at all yet, I would say. And there are many colors outside in the world. I have selected 5 for this lecture. Let me start with sources where we have hydrogen in connection with carbon, for example, in plants. I illustrate this as this short, let's say, hydrocarbon chain. One of the most prominent sources is actually natural gas or fossil fuels. In a process called steam reforming, or in gasification, we can produce hydrogen. The carbon that we had initially in the hydrocarbon is released in the form of CO2 in this process. We label the hydrogen through this concept as gray hydrogen. When we then carry out the exact same process, however we are capturing the CO2, store it or use it for other purposes, then we call the hydrogen blue hydrogen. Another source of hydrogen can be biomass. And this is often then treated in a pyrolysis process, where we obtain again hydrogen together with carbon that we can store. We can easily separate it from the hydrogen, we can store it, or we can use it in other products. And this gets the turquoise color. Now then let me show the other side, where we have hydrogen in connection with oxygen. That means we are using water as the hydrogen source. Here we can apply a process electrolysis, where we split the water into hydrogen and oxygen. And this gets the green label. Sometimes people want to know where the electricity for the electrolysis process comes from, and then they have invented a new color. Again, here as an example, the pink color means that the electrolysis gets the electricity from nuclear power. So this is a short introduction of the different opportunities to obtain hydrogen. Now let's have a look where we get the hydrogen from nowadays. And this is shown in this figure here. It's a report by the European Commission and illustrates nicely the challenge, because you see here more than 90% of the hydrogen is actually obtained from fossil sources. And the other next biggest segment is when it is made as a byproduct from other processes. So all these processes we label more green or bluish, they play a minor role nowadays. Please keep that in mind when we are envisaging hydrogen use, additional use in different sectors. How is it actually being produced, and what emissions, what energies, what sources have been involved? So then, where are we using hydrogen? You see two main sectors. One is refinery, it's this one. Refinery is a chemical industry where we tailor hydrocarbons towards needs in chemical industry, in energy, in transport. Here we, for example, make ethylene for plastics production. We make gasoline, diesel, kerosene for transport, aviation, shipping and so forth. We make paraffins. So we make all the basic chemicals for our chemical industry and also the fuels for our transportation. Another big sector is here, the green one, and this is ammonia. And why do I want to underline that? Then please let me show another figure. Here you see the world's population development over the years up to 2015, and the red curve shows how many people we could support on Earth without using synthetic fertilizers. And this is our actually world population up there. You see that roughly half of the world's population only survives because we have synthetic fertilizers, and many, or most of them are actually based on ammonia as the basic chemical to produce them. So keep that in mind. Hydrogen use is a big sector is for ammonia production and synthetic fertilizers, and that is of course something we have to consider in the future as well when we want to use hydrogen potentially in many other sectors. That leads me to the many other sectors. So why is it so interesting to talk about hydrogen these days? Why? That is because we are in a period of energy transition. Right now our energy system is based on fossil fuels, on coal, natural gas, oil. And in the future, as soon as possible, we want to transform to an energy system based on renewable energy sources, solar, wind, waves, biomass, preferentially biomass waste. And then, okay, what is then the challenge? Let's have a look where we are using energy. And here this is a good illustration, even though the figures are from 18. A big part of our energy goes to the transport sector, then residential and the industry. So these are three sectors that need a lot of energy, and that is something that we also want to give to the society in a new energy system based on renewable energy sources. And how can hydrogen fit into this picture? There is here one illustration from European Commission. We all know that the renewable energy sources are fluctuating in nature. That makes it, that requires that we are able to store this energy, and that we are able to have a buffer as well. And here hydrogen can play a role. The primary product is of course electricity, but electricity storage on a large scale, transportation, there can be challenges. And then in that case, in that scenario, hydrogen convert the electricity via electrolysis to get hydrogen from water is a good opportunity to buffer the fluctuating energy, and also to store the energy, to transport it, and to make it usable in the energy sector. And then we have the energy sectors already outlined in the previous slide, where hydrogen can play a role either by combusting hydrogen or by using it in fuel cells to produce electricity. These are a few, let's say, roadmaps that point to the opportunities with hydrogen. However, hydrogen is not the silver bullet that solves all challenges. We have to consider many opportunities, and that is illustrated in this figure here. We are starting from the needs we have to fulfill on the left-hand side. Then we have renewable energy sources. In it is of course it is needed to consider if we not use electricity directly after production. So we produce electricity from wind turbines. So the first consideration is, can we not use this electricity directly? And that is shown here, means we should consider all opportunities of direct electrification of energy services. If that is not possible for some reason or the other, then we also have the opportunity of energy efficiency, and then the hydrogen that can play a key role in this scenario. I have listed here, or in this illustration, there are different segments. There's heating, steel making, fuel cells, green ammonia for fertilizers or potentially other applications, methanol, and fuels for aviation. And in all these segments, hydrogen can be used either by combusting hydrogen, use it as a molecule, using it in fuel cells, or in what we would call power-to-X scenarios. So here, hydrogen as hydrogen or as a hydrogen carrier and other compounds can play a significant role. Then let me summarize. Hydrogen is the most abundant element on Earth. However, it is only found typically together with other compounds, with hydrocarbons or water. It is a well-known and well-established ingredient in industry, so we don't need to invent a lot of new things to storage, transport, and so on. So it has been known very well for decades in the industry. It has a large potential to also play a role in sustainable energy systems. And with that, I would like to finish. Thank you for your attention.